Okay. Hello, Cardiff. Hello, Cardiff. I'm Aviad. Very happy to be here. Okay. I'm going to talk about observability in your serverless application. So we're going to go over the different challenges that you might have. The main thing I want you to get out of this talk are the different options you have in order to get observability, in order to make your life easier when you're troubleshooting and debugging your serverless environment. So the agenda is, we'll go how serverless changes everything, and then why you need serverless observability, the main challenges, and as I said, go over the different solutions, and you can see which solution is best for you. 2 words about myself. I'm a CTO, co-founder of Lumigo. Spent the last 15 years in the software industry, different roles in R&D, last 2 years in Lumigo. And what we do in Lumigo is we're a monitoring platform. We do observability, troubleshooting, and the main thing is our whole backend is totally serverless. So a lot of things I'll be sharing with you today are challenges that we found and we needed to find a way to overcome, and these are the ways we did it. So before we start diving in, just to be all on the same page, what is serverless? I'm not going into the definition, but when I say serverless, I'm talking about much more than just Lambdas or any other FAS in the other cloud vendors. I'm talking about the whole building blocks which allow you together to build a full application in the cloud without touching any server. So you'll need probably some kind of database or file storage, API gateway or AppSync. All of these together are your serverless environment. Worth mentioning that a lot of times when we see serverless environments, we also see usage of SaaS products. So they're also part of your environment. They're indeed SaaS, but when you look at observability, you need to understand what's happening with your third parties as well. What's the latency, what errors you're getting. The observability doesn't end at the border of your AWS account. So what's the main serverless impact when we're talking about monitoring and observability? So first thing, we're talking about nano services. You have nano services in your applications. Even if you didn't know this, congratulations. All those Lambda functions in the DynamoDB tables, S3 buckets, they're all running independently. Now you can tie them all together in different ways, in logical ways, and then you can call them microservices, which is true. But in the end, each one of them runs independently. So you have nano services, and because it's nano services, you have a distributed environment, and the more nano services you have, it's more and more distributed. So a lot of times you're going to use asynchronous patterns in order to keep your environment scalable and resilient. You want to find different ways to decouple the different services. So if one goes down, it doesn't mean that all of them are going to have a cascading effect and everything is down. If one of them has a surge in usage, it doesn't mean that everybody is going to suffer. So you're going to put different queues or buckets, anything in between, in order to decouple your system. Another thing it means is you're using a lot of fully managed services. In the end, that's serverless, right? So that's very powerful for you as a developer. It's very easy to add just another service. It also means that if you want to get some more information about this service, you don't have any place to plug in, to add an agent, to connect to the server and SSH and get that information. So you need to think, how can I get that extra information in different ways? It also means that your environment is probably more dynamic than it used to. Just because it's so easy to add one more API, one more table in DynamoDB. So it's very powerful for the developers. It means their architecture is always the way they want it to be. But it also means that maybe the architecture today doesn't look like the architecture looked like 1 week ago, 2 weeks ago, becoming more and more challenging to be up to date about how does my architecture actually look like. third thing is cost paradigm shift. It's a whole subject on its own. I won't get into it. The reason I'm mentioning it is, again, it's a real driver for people to use asynchronous patterns in their serverless environments. You want your Lambdas to run as little as possible as a rule of thumb. It's not like a server where you already paid for it and now the code can run and run. You want to use maximum CPU. You pay as you go. So everywhere you can, you start using the Lambdas in parallel, not having one Lambda waiting for another Lambda where it doesn't have to. And this all affects your asynchronous patterns, which make the observability just a little bit more challenging. So let's talk about the specific challenges. One is identifying and resolving issues. We're going to look at an example in just 2 minutes, but the main thing here is when a Lambda fails, a lot of times the root cause is not in that Lambda. You need to somehow find the root cause. It might be upstream, and because you have a lot of microservices or even nanoservices, as we said, it becomes harder and harder to find that specific root cause. You somehow need to understand the story of the specific transaction and why it failed. The second thing is visibility. When I say visibility, I'm talking about the ability to step back and look at your system as a whole. So you have a lot of different moving parts. You can get a lot of information about each of those parts, but sometimes you want to understand how do they all correlate together? Which one affects another? What will happen when I make a change in this kinesis? Which other Lambdas are going to be affected by that? So seeing the whole system becomes much more challenging when you go to serverless. Now, before we take a look at the example, I just want to say when I talk about asynchronous pattern usage in Lambdas, I'm not only talking when one Lambda calls another Lambda asynchronously, I'm also talking about different patterns that we see. We have a lot of these patterns in AWS Lambdas, but in any serverless environment. So in this example, we have one Lambda, which is calling synchronously to the DynamoDB. But implicitly, it's actually calling the second Lambda asynchronously, because that DynamoDB is going to call a stream, and eventually the second Lambda will be called. And although they're not directly connected, I still very much want to understand how they are connected. By the way, this example is taken from Jeremy Daly's website. It has a lot of information about serverless. I use it a lot. This specific post is about serverless patterns, so highly recommend it. So now let's take a look at an example about troubleshooting serverless. In the end, that's the main reason you want observability, to be able to troubleshoot as quickly as possible and spend as little time on it as you can. So let's say it's 2 a.m., Saturday night, and you get an alert. You have a Lambda, it's failing, and now you need to decide what to do. So first of all, you probably did something good because you set up an alert and it works, and you know that something is going wrong. Now, the next thing you want to do is understand the severity of this failure. Let's say you have 2 different services that your company has, and you want to know which one of them this Lambda is affecting. This can be very important because maybe these 2 services, one is process payment. This is the way your company gets all its money, and if it's down, that's really, really bad. Maybe the second service is LaunchBot, which is very important, but basically what it does is tells your developers to go to lunch every day at noon so they won't spend the whole day in front of their computer. So if it's Saturday night, 2 a.m., maybe that can wait. So you start looking up. You want to go upstream and understand this Lambda to which service is it connected. Now you have to remember, this Lambda might not be yours. It's not necessarily you wrote it, so you don't know immediately to who it belongs. So you start going upstream. You see it's triggered by an SNS. You dig some more, you see that SNS is triggered by a Lambda. But now you're starting to understand this is taking too much time. I can't spend so much time just to understand what's the impact. Now, let's say you have a very, very diligent architect, and he's keeping a map of your system up to date at all time. This, first of all, means that you're very lucky that you have someone who's doing this. This architecture, by the way, it's a real architecture done by Jan, who spoke in the very beginning, our developer advocate. This architecture has over 150 Lambdas in it. And now I know that that Lambda down there has a failure, and I hope to be able to connect it through the map to the specific service. So, OK, it's the bad one. This is the one I have to take care of. I can't go immediately back to sleep. So maybe I also want to understand the exposure. Maybe this is affecting only one customer. Maybe it's affecting all my customers. So I need to dig down and not only see the general connection, the general flow which connects the Lambda to the API gateway. I want to see the specific data, which requests arrived at the API gateway and made the way all the way to the Lambda when it failed. So now I need to see the specific transactions. Next part is probably I have to debug it. OK, now I really woke up sitting next to the computer trying to fix the issue. First thing I want to do is understand exactly when it happened. So now we're starting to get a little bit into the solutions about how you can do this yourself. So first thing you can do, you can open up Cloudwatch metrics to see exactly at what time the failures occurred. Then you probably want to go to Cloudwatch logs and search for those failures. No easy way to get from one to the other, but you can do it according to the timestamps. Now, next thing is extract the specific debugging info in order to understand how can I fix the issue. Now, again, you're going to Cloudwatch, and the data you have there is the data you remembered in advance to generate logs about. So if there's something missing, you'll need to add another log, maybe redeploy, and wait for reproduction in order to get it. Everything you can find in Cloudwatch. And now, last thing, distributed tracing. You need distributed tracing in order to be able, to go upstream and start finding the different Lambdas along the way. You need to be able to make that connection in order to find the root cause. In this example, we see we have a bug a few Lambdas away. So how do you make those connections? If you don't have something in place, you'll need to dig inside your Cloudwatch logs and look for specific correlating, maybe IDs, maybe messages that you have, and each pair of Lambdas make that connection until you're able to climb up to the problematic Lambda. So again, you do this, you have the different Cloudwatch groups, and then you have to go into Cloudwatch streams. You also have Cloudwatch insights, which give you better ability to search, but you can't search the whole system at the same time. And then you'll find the problematic Lambda. So let's talk now about the solutions, the different ways you can troubleshoot your system. A lot is about the distributed tracing. This is usually the main part which makes it harder in serverless. So we're going to talk about three family of solutions. The first one is the one that we just saw, which is using Cloudwatch and Friends. You have Cloudwatch metrics, logs, alerts, insights. You also have X-Ray, which is a friend of Cloudwatch. This gives you some distributed tracing, allowing to see some of the connections along the way. And when using Cloudwatch, a lot of this is based on searches in the different log groups. So pros, this is out of the box. You get it without having to install anything. You also have AWS support, which is cool. The cons, it's complicated. The different services of Cloudwatch are not directly connected. You have only partial asynchronous support. So X-ray doesn't do the connections between all the different lambdas. So for example, Lambda, Kinesis Lambda, you won't be able to see that connection in X-ray. It's hard to query. Cloudwatch Insights does a good job, but still it's not things like Elastic. And last, it's hard to understand the overall business impact. You see very specific issues, but it's hard to see the big picture. So this is a great place to start with, but as your system becomes more complex, you'll probably need some more advanced tools. So second option, these solutions are your homebrewed solutions, meaning these are changes that you can add to your code in order to get better visibility. So first of all, you can do it yourself. Basically, what you need to do is to generate a correlation ID for every new query that enters your system, and then you need to propagate that ID throughout all the calls the lambdas do to the different services. So pass that ID every time the Lambda makes a call. For every service, you need to pass that ID in a different way. For Lambda, for SNS, for SQS, everywhere you need to add that ID. And you're making small changes to the data that's being passed. So it's not invisible. There are actual changes in the data. You have to make sure that all your teammates and all the different teams are on board. You need them to all be looking for this ID, or else things will break between Lambda that are using it and Lambdas that are not using it. And probably what you want to do is create some kind of library for every service, right? You don't want to add code in each and every Lambda. So you still have to add code, but add as little as possible. Create libraries for each of those services. Last thing you want to do, make sure that you generate logs with that correlation ID. That will allow you to use that ID every time something goes wrong, and you can search for it and find all the correlated Lambdas. So again, you don't want to have each and every developer remember adding that ID to the log, so just add it to your logger. And then you probably want to use some aggregation tool, just because when you have those correlation IDs in your logs, you want it to be very easy to search for them. So you can use any Elastic or Loggly or Logs.io, whatever you like. And you can use open source, which already does some of this. You can use them either as an example, or you can use some of the libraries. So here we have an example of the Lambda Power Tools, which does this for EventBridge. And you have a different library for each and every AWS service you'll need to wrap. Second type of homebrewed solutions are frameworks which do distributed tracing, but they're not built specifically for serverless. So again, you can take these open source options, Jaeger, Open Tracing, the other ones as well, and you need to add them for every part of your code that you want to trace. And then you can install a server. Yes, you need to install a server and collect that data, and then you can start seeing transactions in your system. So for this option, the pros, it's tailor-fit. It's specifically for your code because you're adding it to your code. It's supported by many vendors. It's not cloud-specific. Again, it's running inside your own code. And the cons, it's very high touch. You need to know exactly what you're doing. You need to know where you want to add it. And you're making changes. So every time you want to add it or you want to remove it, you need to do it in the correct way. And some components will still not be supported, like, for example, API gateway. If you're going this way, I highly recommend Jan's blog post about this. This is in the Burning Monk. It shows how to do it step by step and how you can use some of the open source out there. Third option is using a serverless monitoring platform. There are several out there. And basically what these do, they're SaaS platforms. They connect to your system. They do automated tracing without you having to change your code at all. They give you more than tracing. For example, they help you understand your cost and other things you want to get inside your serverless applications. In general, the way they do this, they add some kind of library to your Lambda. They can do this using Lambda layers or any other way, but you don't have to add lines of code. And also connect to your system using IAM roles. So you do those two things, and you get the distributed tracing. Pros, it's very serverless focused, so you get a lot of extra data that's only relevant for serverless. It's more than just tracing. And I think maybe the main point here, it's very low touch. The cons is it's yet another third-party application that you need to add to your system. So in some places, that's not easy to do. And it's more than just tracing. So if you're looking for a very specific solution, you'll need to deal with a little more than that. Now let's take a look at an example how you get this information. So once you're connected, you can see a system map, getting an overview of your whole architecture, seeing what is connected to what and which effects you're going to get when one of the microservices or nano services is changed. You can also see all of your transactions in one place as they're happening. So for each transaction, you can see the different components. You can see if it had an issue, the overall duration of the transaction. And then you can dig into each and every transaction. So if, for example, we said we have an issue on one of those Lambdas, I can very easily see what were the Lambdas that were called before it. I can go upstream, even if there was an SNS or Kinesis or S3 bucket between the different Lambdas. And then when I find something which is suspicious, I can dig into that and get some more information, even more information that you added to your own Cloudwatch logs, because the library knows how to pull interesting information. So for example, you'll see all the different retries correlated into one place. You'll see not only the exception, but you'll also automatically see the input the Lambda got, the event of the Lambda. So all these little additions usually can make your life much simpler. And when you're debugging and troubleshooting, that makes the difference between having an hour of troubleshooting and 2 minutes of troubleshooting. That's it. The main takeaways that we talked about is how serverless changes everything. We're going to nano services. We have a lot of asynchronous patterns, and your system is highly distributed. And we talked about the 3 different solutions which you can use, the out-of-the-box AWS solutions, the homebrewed, which you add to your own code, and the SaaS platforms, which give you all of this automatically. So thank you very much. One more thing, we have a booth over there, and we have a raffle for a drone. So everybody that wants to have a chance, just enter your name over there, and at the end of the day, we're going to do the raffle. Thank you very much.